Oh, no, I need you to do class. Okay, hold on. All right, let me teach. It says, what do you know about a deck of cards? Brian, tell me something you know about a deck of cards.
I just want to say once upon a time we were born was frozen.
Oh, thank you. What do we know about a deck of cards, though?
It consists of 4 suits.
4 suits. What does that mean? I don't know. That's why we're talking about it right now. We got to make sure we do know. 4 different types of shapes. Do you agree that there are hearts?
Yes.
Diamonds? Do y'all know what the other 2 are called? Clubs and spades. All right. This right here, this shape right here is called a spade. And this leaf-looking 3-leaf clover is called a club. And then the heart and the diamond I feel like are obvious, right? All right. So there are 4 different suits. Do we know how many cards are in each suit? Because this matters for this week. Next week. There are 13 cards. There are 13 cards in a suit. 2 through ace. All right. So that is something you need to know to do what we're doing. Okay. Next. How many cards are there total in a deck? There are 52 cards in a deck. Did you know, ladies? Did you know there are 52 cards in a deck? No. There are. You need to know that. So 52 cards in a deck, 13 cards in each suit.
I learned that after someone said 52 pairs.
Correct. That's a game.
What is the suit?
Suit is like the different shapes.
It's an awful word.
All right. What else do we need to know about cards?
What?
What else do we need to know about cards? What else do you know?
Cards are paper.
What?
Blackjack.
Let's talk about the color of cards. How many different colors? 2 different colors. And how many of each color are there?
1.
How many cards are black? How many cards are red? What's half of 52? Exactly. There are 26 red cards and 26 black cards. Okay? I don't think you need to know. Oh, and then the suits we talked about. All right, now, something else I need you to know is about dice. What do we know about dices? Die. They are not squares, but they are square faces. But what shape is a dice? A cube. And how many faces does a dice have? They have 6 sides. So that is going to come into play when we are dealing with die later on. And then what about a coin? If I have you flip a coin, how many faces does a coin have? 2. Do y'all agree? And what are the faces? Heads and tails. Okay? I know this seems obvious, but you have to know this stuff in order to do what we're about to do. All right. So these are all common situations where you might need to know or use probability to figure out chances. Now, what is probability? Probability is the chance that an event will occur. What is the chance that you will pull a red card out of a deck? What is the chance that you will flip a heads on a coin? What is the chance that you will roll a 2 on a dice? So these are the different things. Probability, you're looking up, please, is an outcome as possible result from a probability experiment. We're going to learn about that on Monday. And the measures of how likely an event is to occur is you are going to divide. What are you going to divide? Your wanted outcome divided by the total number of possibilities. So, what is the probability you will roll a 3 on a dice? Why 1 in 6? Do y'all agree there are 6 total sides? Do you agree there's only 1 3 on a dice? So you have a 1 in 6 chance of rolling a 3. Be careful, because you know what a lot of people tell me? They tell me, Miss Alvarez, you got a 3 in 6 chance. Why would they say that? Because the number is 3. But how many times does 3 appear on a dice? Only 1 time. That's why it's 1 in 6. All right. What is the probability of tossing a heads on a coin? Well, how many heads are on the coin? 1. How many total faces does a coin have? So it is 1 out of 2. What's the probability of pulling a black card from a deck? Do y'all agree there are 26 black cards? How many cards are there total? So it's a 26 out of 52. Now, that's not the only answer. It's also 1/2. How many black color options are there for cards? There are two options. How many of them are black? 1. So it's 1/2. Okay. Also, if you put 26 over 52 in Desmos, it would tell you and reduce it to 1/2. Okay. Last but not least, I have this beautiful spinner. What's the probability that I'm going to land on red?
1/4.
Why 1/4?
There's one red.
There's one red, but there are 4 different colors. Okay? Now I'm going to make up a situation. I have a bucket. I have a bucket. In this bucket, I have 2 red markers. I have 3 blue markers, and I have 1 black marker. What is the probability that I am going to pull a red marker out of here? 2 out of 6. Do y'all agree there are 6 pens in here? And do you agree there are 2 options for blue? What's the probability I'm going to pull a blue marker out of here? Blue? 3 and 6 or 1/2. Do y'all agree 3 divided by 6 is half? And then what's the probability I'll pull a black marker out? Okay, so that's probability. Just take your wanted outcome and you divide it by the total. How many there are versus the total. Now, independent versus dependent. The outcome of one event does not affect the probability of another if it's independent. Okay? Independent things would be like, and this is if you do 2 things. So let's say I go to Las Vegas and I win if I roll a dice and I flip a coin. And they're like, okay, you can win if you land on a 1 and if you get a heads. Do you agree those are 2 different events? Does rolling a 1 have anything to do with flipping a heads on a coin? No. That is independent. Those 2 things are independent of each other. Okay? Dependent is when the outcome does affect the probability of another event. For instance, what if I go to Vegas and they're like, if you roll a number greater than 10, you win. Well, that first dice I roll, does it matter what I get when I roll the second dice in order to add up to 10? Yes. So that's dependent because your probability depends, these 2 events depend on each other.
But why doesn't the first example?
Because when you, does rolling a dice affect you flipping the coin?
I thought it said if you landed on something and then you also needed heads.
Yes, but it's saying as in, okay, so if you roll a dice and you flip a coin, those are 2 different actions. They're not the same exact.
Right, but so my probability, my goal, like what I was supposed to get, does flipping the coin depend on, like how I flip the coin, does that going to change my outcome of the dice?
Like what you land on?
Right.
Yeah,
Right.
because you just said that you needed heads on the coin.
Right, but if I do them at the same time, let's say I do them at the same time.
Yeah, it does, because you said you needed like a certain number.
Okay, I get what you're saying. Let me rephrase what I'm saying. Because I get what you're saying, like, oh, if you never get the 1, then it doesn't matter if you get the heads. Right, but that's not what I'm saying. What I'm saying is, let me think of a different example that'll help explain this to you. If I, here's a good example. Let's say I need to draw a marker, or not draw a marker, but pull markers from this bucket, right? So if I pull a marker, take it out, and I do not put it back in, don't you agree, go back to this page, don't you agree that's going to change my probability the second time I pull a marker? That is dependent, because what you do the first time changes your outcome for the second time, right? It is a little bit confusing. It'll make more sense as we do examples. But, so that is dependent. If I do not replace what's in this bucket, then my second draw depends on whatever I do the first time. right? For independent, if I were to pull a marker and I were just to put it back, don't you agree the probability would be the same regard? So that's independent because it doesn't matter because I replaced it and we moved on. Okay? The same way for the dice. If you roll a dice and you're trying to get above 10, if I get a 1, isn't that going to change my probability versus if I get a 6? The first roll. Change how? Like, okay, so what is the probability that I will roll a 1?
1 out of 6.
1 out of 6. But now, what is my goal? What was my goal?
Did you say 10?
To 10. So what's the probability that these 2 dice are going to add up to 10 after my first roll now?
2 out of, wouldn't it, because you have 2 sides.
Right, but I have 1 dice and I just rolled a 1.
1 dice, I see.
I just rolled a 1. Now I have to roll it again.
You have to get-
Can I get 10 at all? No. So now my probability just went from 1 out of 6 to 0 out of 6. There's no chance. You know what I mean? Okay. So this second number right here will not always be the same because it all depends on what I roll on my first dice. Does that make sense? Okay. But if I were to roll the dice and flip the coin, even if I don't get 1, don't you agree I have a 1 out of 6 chance of getting a 1? And I have a 1 out of 2 chance of flipping a heads? Regardless of if I get it, those are my chances and those are never going to change. They are independent of each other. No matter what, flipping a coin, I have a 1 out of 2 chance of flipping that heads, regardless of what I roll. But for that second example, depending on what I roll, that changes my probability of adding up to 10. We're going to go over it more.
So when you go to the 6, 4, 5, 6, 4.
Right, exactly. So that's exactly. And depending on which one you get, that's going to change the probability of the second die. All right, independent probabilities. When you toss a coin, roll a dice, draw a card, and you replace it. Independent is if you are drawing something, you have to replace it to be independent. Or spinning a bottle or spinning a wheel. Dependent is whenever you do not replace something, or when you're trying to add up to something, or when you're trying to multiply to something. All right? That is our lesson for today. I did it in 12 minutes. You are now going to go into Schoology, and you are going to complete the Schoology assignment under the probability unit. It's called Intro to Probability Practice. You have the rest of the class period to make an A or a B on this, and then we are done for the day. Let me stop recording. Bye. Thank you for watching. Oh.